Hello everyone, welcome back to the channel. In this video lecture, we shall solve this problem container with most water. In this problem, we're given an integer array height of length n and there are n vertical lines drawn such that two endpoints of any ith line, namely I0 and I height. So we have to find two lines that together with the x-axis forms a container such that that container contains the most water. We have to return the maximum amount of water that a container can store. So in this diagram, we can see that we are given these lines and these lines are represented by the integers which are given in the height array. The input will contain an array of n integers where each integer represents the height of the bar at that location. In the output, we have to return the maximum amount of water which we can store by taking any two of these heights such that the water stored is max. Let's better understand the problem statement using an example. So here is an array height which contains 8 integers. The first integer is 1, which represents a bar of height 1. The second integer is 8, which represents a bar of height 8. The third integer is 6, which represents a bar of size 6, and so on. Here, how many containers we can form? You can see that, let's say we stand at first bar here. If we choose this bar as the first bar, then how many options I have to choose my second bar? 1, 2, 3, 4, 5, 6, 7. So I have 7 other options to choose my second bar. So I can make one container like this, another container like this with this bar, a third container with bar of height 2, and so on. I can make 7 containers. Similarly, with this bar, I can create 6 containers. Hence, I have total for any array of heights n, I have roughly n square containers. But out of all these containers, I see that this container where I choose one of the heights as 8 and another height as 7 will contain water equal to 7, which is the minimum of these two heights, multiplied by the base, which is, since all of these bars are 1 unit apart, the base would be 1, 2, 3, 4, 5, 6, 7, 8, 8 minus. So since these two bars are 6 units apart, 1, 2, 3, 4, 5, 6, the base length would be 6 and the height of the rectangle that is formed by these two bars would be minimum of the heights of these two bars, that is 7. Therefore, the water that it will store will be equal to the area covered by the rectangle formed by these two bars, which is 42 units. And that's the answer for this. So what is the strategy to solve this problem? Let's see how we can solve this problem. The naive approach to solve this problem is to consider all the n square containers. That is, I take a pointer I, start from the first bar, then I take another pointer j, which I start from the bar which is next to I, that is I plus 1, and I consider each and every container. So first I consider this container. So this container will have area as minimum of these heights, which is 1, multiplied by the base, which is 1. So 1 into 1, this rectangle would have area of 1. Then I will move my j to next bar, that is this bar, and I will consider this area. I'll consider this rectangle, and the area of this rectangle would be minimum of the heights, which is 1, multiplied by the number of units the bars are apart from each other, which is 2. Hence the area would be 1 multiplied by 2, that is 2. Then I move my j to next pointer and so on. Out of all these rectangles, I will take that rectangle which has maximum area. So this is how a brute force solution works. Let's see the implementation of the brute force solution. So this is how we implement the brute force solution. This is the max area function. It takes in the height array, initializes answer with 0, calculate the size of the array. Then I iterate over the array, height array, starting from the first element, and for each element I start from the next element, which is I plus 1, and I consider these rectangles. The first rectangle of heights 1 8, then 1 6, then 1 2, 1 5, and so on. And here I am calculating the height, which is the minimum of the heights which we are considering, and base, which is the number of units these two pointers are away from each other, and finally the current area, height into base, and I will update my answer with this current area. Then I move my I to next integer and j here, and then again consider this rectangle, then this rectangle, and so on. So I take all possible rectangles and I keep updating my answer, and finally I extract my maximum area here and I return it right from this. So this is how a brute force solution is working. Let's discuss the time and space complexity for this solution. We can see that we are iterating over this array once here, then for each point I am again iterating over the array once. So since it is a nested loop, we have n square time complexity, while the space complexity is constant because I am not using any extra space, hence constant space complexity. So this is the time and space complexity, quadratic time complexity and constant space complexity. Let's discuss a more optimal solution, because this solution is not going to work for n of size, let's say 10 raised to the power 5, because 10 raised to the power 5 into 10 raised to the power 5 would become 10 raised to the power 10, and which is beyond the number of iterations which are done in 1 second, that is 10 raised to the power 8. Hence, let's discuss a better solution for this problem. The better approach to solve this problem is 2 pointers. Why do we use 2 pointers? Let's see that. Okay, so in this solution I initialize 2 pointers. The first pointer I stands at the starting bar and the second pointer j stands at the last bar, and we calculate the area covered by these pointers. So initially the area covered by these pointers would be minimum of 1 and 7, that is 1 multiplied by the number of units these bars are away from each other, which is 8, and the area is 8. Then the strategy of the pointers is that I will check if the height at j is greater than the height of the bar at I. If it is the case, then what is the optimal move? The optimal move would be to move I to the next bar, because I already have the result by considering this bar. Hence, the optimal move would be to move I to the next bar. So I is here, because we are assuming maybe we would find a bar larger than this bar here. Then I again calculate the area, which is minimum of these heights, that is 7 multiplied by the number of units these bars are away from each other, which is 7, and the area is 49. So area covered by these bars is 49. Then I again compare the heights. The height at pointer I is 8, while the height at pointer j is 7. So the optimal step is to move the pointer j to the previous bar. So I move the pointer j to this bar. Then I again calculate the area, minimum of these heights 8 3, that is 3 multiplied by the number of units they are away from each other, which is 6, which is going to give me 18. Then I again compare the height, and the height at j is less than the height at pointer I. Hence, the optimal step would be to move j closer to I. So j is moved here. I again repeat the step, and similarly I keep on moving my pointers close to each other and keep updating the answer. So finally, okay, so this is the final configuration I would have. The pointer I would be at this bar and the pointer j would be at this bar for this particular case, and these are the results which I computed during my traversal of this array. And I can see that if I keep updating my answer variable starting from 0 with these values, which are the areas of the rectangles which I found on the way, then answer would contain 49, which is indeed the answer for this case, because this is the area here which contains the most water, and this area has a size of 7 multiplied by 7, which is the base, that is 49. So this is how I solve this problem using 2 pointers. Let's see the implementation for this approach in the next. So here you can see max area is a function which takes in the height of the bar, and I calculate the length of the array. Then I initialize 2 pointers. First pointer stands at the starting of this array. Second pointer stands at the ending of this array. I initialize my answer variable with 0. Then I move my pointers until they are not at the same position. Then I calculate the height, which is the minimum of the height at pointer I and pointer j, while I calculate the base, which is the difference between the locations of these pointers, namely how much these pointers are away from each other. Then I update my answer variable. Here is the strategy to move my pointers, which is if the height at pointer I is greater than the height at pointer j, then it would be an optimal step to move pointer j closer to I. Otherwise, move pointer I closer to j. Finally, I return my answer right from here. Okay, so this is how the function is working. Let's discuss the time and space complexity for this solution. You can see that we are traversing over the array single time. Hence, the time complexity would be linear, while we are not using any extra space. Hence, the space complexity would be constant. So this is the time and space complexity. Let's see the implementation for this solution. So this is an optimal solution. Let's try to implement it. Okay, so this is my max area function. I'll first calculate the size of this array. Initialize 2 pointers, one with the starting index and second with the ending index. Initialize answer variable to store the final area. Then move these pointers with this strategy such that until they are not at same location, and keep updating the answer. Okay, so at each I and j, so initially I is at the first index, j is at the last index. Find the minimum of these heights, find the number of steps these pointers are away from each other, and find the area of the container and update the area. Then move these pointers according to this strategy. Finally return the answer right from here. This is how this function is working. This is the implementation in C++. Let's see the implementation in Java language. So this is the implementation in Java, and this is the implementation in Python language. So I have attached this code in the description, so make sure to check it out. That's all for this video. If you liked it, then make sure to spread the word, and I will see you in the next